Good day. I am Ruth Ann Imanil and I will discuss flotation equipments. Various types of flotation machine designs can be classified into different categories based on the methods used for the generation and introduction of air bubbles into the equipment. It is illustrated in the following slide. Each of the techniques of air bubble generation and particle bubble contact, along with special features associated with different kinds of equipment, has its own advantages and limitations. These must be considered carefully in selecting the equipment for a specific application. Individual manufacturers can provide basic help in selecting the equipment. Let's first discuss electrolytic flotation units. Electrolytic flotation units, also known as electroflotation, is based on the generation of hydrogen and oxygen bubbles in a dilute aqueous solution by passing direct current between two electrodes. Choice of electrode materials include aluminum, platinized titanium, titanium coated with lead dioxide, and stainless steel of varying grades. Electrical power to the electrodes is supplied at a low voltage potential of 5 to 10 volts. The power consumption is in the range of 0.5 to 0.7 kilowatt per square meter of flotation tank surface area, depending on the conductivity of the liquid and the distance between the electrodes. Such a unit produces approximately 50 to 1 of gas per hour per square meter of tank area. The picture below this slide is a schematic diagram of an electrolytic flotation plant. Let's proceed to the second type of flotation equipment, which is the dissolved air flotation units. Dissolved air flotation entails saturating the process stream with air and generating air bubbles by releasing the pressure. Particle bubble contact is achieved by the direct nucleation and growth of air bubbles on the particles, and very little mechanical agitation is employed. The dissolved air precipitates in the form of fine bubbles in the size range of 20 to 100 micrometer. This method of air bubble generation does not require the addition of flutter-type chemical reagents and often limits the total quantity of aeration possible. As such, dissolved air flotation systems are used to treat process streams with low solid concentration of 0.012% by volume. Vacuum flotation and pressure flotations are the two main types of dissolved air flotation processes, with the latter being most widely used. In vacuum flotation, the process stream is saturated with air at atmospheric pressure and introduced to the flotation tank. Then vacuum is applied, giving rise to the generation of the air bubbles. The process can be run only as a batch process and requires sophisticated equipment to produce and maintain the vacuum. By and large, the amount of air released during flotation is limited by the vacuum achievable. In contrast to vacuum flotation, dissolved air flotation units can be operated on a continuous basis by the application of pressure. These consist of pressurizing and aerating the process stream and introducing it into the flotation vessel that is maintained at atmospheric pressure. The reduction of pressure results in the formation of fine air bubbles and the collection of fine particulates to be floated and removed as sludge. This is an illustration of a dissolved air flotation plant. Did you know that dissolved air flotation units are widely used in wastewater treatment industries? Let's now discuss dispersed air flotation units, which is the third type of flotation equipment. Dispersed air flotation involves the generation of air bubbles, either pneumatically or by mechanical means. In both cases, relatively large air bubbles of at least 1 Mechanical flotation machines are most commonly used in the mineral industry, while pneumatic column type units are gaining popularity in recent years. Surveys by Harris, Young, Barbary, and Mavros provided a detailed overview of the process engineering aspects of mineral flotation devices in particular and systems in general. Mechanical cells is the first type of dispersed air flotation cell. Mechanical cells is characterized by a cubic and cylindrical shape equipped with an impeller surrounding by baffles with provisions for introduction of the feed slurry and removal of froth overflow and tailings overflow. The machine received the supply of air through a concentric pipe surrounding the impeller shaft, either by self-aeration due to the pressure drop created by the rotating impeller or by air injection by means of an external blower. A mechanical agitator draws in air and beats it into the pulp. Agitation is more violent and tailings are more or less free from the desired material in the concentrate. The following slide illustrates a mechanical flotation cell. Examples of mechanical cells are the following: Callow cell, which contains horizontal blankets with several layers of cloth fastened to frames where the compressed air passed through. It needs special care when cleaning the blankets to prevent tearing of cloth. It is used for solids that are easily floated without great agitation. Second example is the Callow Macintosh cell. Air passed through by means of a perforated rotor made from steel tube and covered with either perforated rubber or cloth. Cloth does not blind easily due to rotation of the tube. The following slides are other examples of mechanical cells. The second type of dispersed air flotation cell is pneumatic cells. Pneumatic cells depends upon compressed air for mild agitation. Included in pneumatic cells are flotation column. Flotation columns belong to the class of pneumatic devices in that air bubble generation is accomplished by gas sparging system and no mechanical agitation is employed. Columns are built of long tubes of either circular or square cross sections that are commonly fitted with internal baffling. They are usually 10 or even 15 meters high with a cross-sectional area of 5 to 10 square meters. This is an illustration of a flotation column. Let's proceed to packed column. Packed column represents a minor variation to the basic column design in that it provides for corrugated plate type packing. The packing feature enables uniform bubble size throughout the height, intimate particle bubble contact, increased residence time of the slurry and bubble phases in the column, and a deeper froth zone. This is an example of a packed column. The Jameson cell, by contrast, is a combination column cell design. It includes a vertical downcomer column in which the air and pulp are dispersed into a dense foam of fine bubbles, creating a favorable environment for particle bubble contact. The bubbly mixture is then discharged into a cell, which allows the separation of particle-laden bubbles from the pulp. This is an example of a Jameson cell. Air sparge hydrocyclone is a distinctly different design consisting of two concentric tubes with a conventional cyclone header at the top, providing for tangential entry of the feed. As the feed slurry swirls down in the inner porous tube through which air is sparged, collision between centrifuge particles and air bubbles takes place, leading to the recovery of hydrophobic particles. The bubble hydrophobic particle aggregates are transported into the overflow stream as froth, while the non-floating particles are removed with the underflow. Each of these and other design variations to the basic pneumatic flotation column concept is found to offer process improvements to specific applications. And that's all for flotation equipments. Thank you for viewing. God bless.